Okay, so we're talking today about acceleration. It's going to be very similar to what we did yesterday with velocity. Acceleration is the rate of change of velocity over a time interval. Okay, so if you look at the equation here, acceleration is change in velocity over time. So you're going to write it as this: to change in v over time, or change in v over change in time. If we're looking at 2 points in time, that is. So at like 3 seconds to 4 seconds, how much does it change? You can do it that way too. And when we talk about change in velocity, we're talking about final velocity and initial velocity. So final minus initial over the time taken. Okay. Then we break it down. This is the equation here. Acceleration equals final velocity minus initial velocity over time. Okay. Now, because we can slow down or we can speed up, that means that we can have a positive acceleration. That means we're speeding up, or a negative acceleration, slowing down. Okay. So if we look at the equation here, so this is the equation that I just gave you. That one solves for acceleration. Okay, that one solves for acceleration. We can rearrange it multiple ways. So these are just rearrangements of this original equation. Okay, we can solve for t, we can solve for vf, we can solve for v initial, so initial velocity. Okay, typically I just remember this one and then I just solve for it as I go and as it asks me to do certain things. Okay, so let's look at some problems here. Let's just look at some examples. Okay, so a car starts from a standstill. So that's our first thing, our initial velocity here. It's 0. Then accelerates to 20 meters per second. So that's our final velocity. In 10 seconds. So that is our time. What is the car's acceleration? So we're looking for acceleration. So we're finding acceleration. We don't know that. We know our initial velocity is 0. We know our final velocity is 20 meters per second. And we know our time is 10 seconds. Okay. So we have our equation: acceleration equals v final minus v initial over acceleration. Sorry, not acceleration, over time. Duh. Get ahead of myself here. And then when we plug in our values, we have 20. And our initial was 0. And then our final time, or our time, was 10 seconds. Okay, when we do the work here, we get 20 minus 0 is 20, divided by 10. 20 divided by 10 is 2. And the units are meters per second divided by second, so it's meters per second squared. Okay, so that is our answer. You can think of it this way too. It's increasing velocity 2 meters per second every second. So the velocity is increasing 2 meters per second every second. So it's positive because it's increasing, and it's meters per second because that's what it is. Okay. Next one, number 2. Oops. Okay, number 2. A baseball rolls up a hill at an initial velocity of 10 meters per second. So that's our initial velocity. After 10 seconds, so that's the time, it comes to a brief stop. So brief stop means that the final velocity is 0. And what is the baseball's acceleration? So we're looking for acceleration again. Our final velocity is 0. Initial is 10 meters per second. And it does it in a time of 10 seconds. Okay, so again, the formula is v final minus v initial over time acceleration. Our v final is 0, actually, 0 meters per second. Our initial is 10, so minus 10. And it took 10 seconds to do that. So you'll notice here it's minus, so we're actually at negative 10. And then negative 10 over 10. So negative 10 divided by 10 is negative 1 meters per second squared. So basically, this is just telling us that we're decreasing the velocity over time. So it's going down, it's decreasing 1 meter per second every second. Okay, next one. Example 3. How long will it take a car to go from 10 kilometers an hour, initial velocity, to 60 kilometers an hour, final velocity, when its acceleration is 2 meters per second squared? Okay, so here we have the initial velocity is 10 kilometers an hour. Our final velocity is 60 kilometers an hour. Oops. Our final velocity is 60 kilometers an hour again. And then our acceleration is 2 meters per second squared. And we're looking for time. Okay, so one of the things you probably notice is that the units are not matching up. Okay, we have kilometers per hour and meters per second squared. So we have to convert either the two velocities to meters per second or the acceleration to kilometers per hour squared. So I'm going to do both. I'm going to start with doing the velocities to meters per second, and then I'll finish and I'll do the other one. And you'll see that we get the same answer if we do it both ways. I think converting the velocities will be a little bit easier, and I'll explain that why as I go through here. So here I'm converting kilometers to meters. So kilometers goes on bottom, meters on top. There's 1,000 meters in 1 kilometer. And then I'm going from hours, so hours goes on top, goes opposite. And then seconds on bottom. And there's 3,600 seconds in 1 hour. Same thing here. I'm going to do the same conversions down here. 1,000 meters per kilometer. And for every 1 hour, we have 3,600 seconds. Okay, when we do the math here in our calculator, we get 2.78. And that would be meters per second. And here we get 16.67 meters per second. I'm not really worried about sig figs here. Okay. All right, now we can use these two numbers to find time. So if we look at our original equation, we have v final minus v initial over time equals acceleration. We want to solve for time, so we got to multiply both sides by t. T. Bam, bam. Then divide by a. Divide by a. That cancels. So vf minus vi over a equals t. Okay, if we use those numbers we got before, we have 16.67 minus 2.78 divided by 2 meters per second squared. And we get the time to be roughly 6.95 seconds. Okay, we can also convert, as I said, we can also convert this 2 meters per second squared, but it's a little bit trickier. Okay, we do have to convert the meters to kilometers, so meters on the bottom, kilometers on top. 1 kilometer is 1,000 meters. Okay, and then we also have to convert this seconds squared to seconds and hours. Okay, this is where it gets a little bit tricky because there's 3,600 seconds in 1 hour, but it's not seconds, it's seconds squared. So we have to square both of these. Okay, so we have to do 3,600 squared. Okay, so we're going to do 2 divided by 1,000 times 3,600 squared. And I got 25,920. Okay, 25,920, and that would be in kilometers per hour squared. Okay, so now if we were to take all of these numbers, this one, and this one, and plug it into the original equation, we get 60 minus 10 over 25,920. And we get 1.93 times 10 to the negative third. But that would be in hours. That would be in hours. If we want to compare it to the answer we got before, we just need to convert hours to seconds. So multiply by 3,600 seconds for every 1 hour. And you'll see that we get pretty much the same answer, 6.94 seconds. Okay, so you see how that one's a little bit trickier, a little bit harder to do. So that's why I'd rather convert the other one first. I'd rather convert the velocities. Okay, but up to you and up to what the question is asking you for exactly. Okay, last one here. So what will the final velocity, so that's what we're looking for, be if a car is accelerating at 5 meters per second squared, so that's acceleration, for 10 seconds, that's time. If its initial velocity was 10 meters per second, initial velocity is that. VI is 10 meters per second. The final is what we're looking for. Time is 10 seconds. Acceleration is 5 meters per second squared. Okay. We have our equation. Acceleration is v final minus v initial over t. And we want to solve for final velocity here. So we're going to multiply both sides by t. And then add the initial velocity. So final velocity equals v initial plus acceleration time. We plug in the values. V final equals the initial, which was 10, plus the acceleration, which is 5, times the time, which is 10. And we get 5 times 10 is 50, plus 10 is 60. And that would be your answer. Okay, there you go. Let me know if you have any questions.